morning, guys. This is Utkarsh Grover presenting the fifth question from the probabilities assignment 1. So, here we go. The fifth question states that suppose there are 100 people waiting for a blood test kind of disease. The probability that for one person the test result is positive equals to 1. The two test methods are as follow. So there are two test methods to for the blood test of the disease. So the method 1, test each person one by one, then we have to do 100 tests. So if we do so there are a total 100 people and we go by the first method, then we have to do test of one person one by one and there will be 100 tests. Method 2, divide 100 people into a group of 10 with 10 people in each group, then mix 10 people's blood sample and test the mixture. If the result is positive, then test these. If the blood is if the result is negative, then everyone in the group is negative, and if the result is positive, then we have to test these people one by one again. So then the number of tests become 11. On an average, what is the number of tests we need to do for the second method? So that's our question. So if a person is tested positive, that means the probability of a person getting test positive is 0.1. The probability of a person getting test negative is 0.9. Hence, we consider the second method. So if we go by the first method, it will be like one person getting tested a single time. So there will be total 100 tests for 100 people. That's done. When we consider the second method, as the question asks, on an average, what is number of tests we need to do by the second method? So hence, we consider the second method for measuring the number of tests. We let k is equal to number of tests for each 10 people group. So as the question suggests, to make us a group of 10 people, so we let k is equal to number of tests for 10 people. Now either k can be 1 or k can be 11. If k is if we mix up all the blood samples and test, so if the test is negative, then only we have to test it only once. So that's why 1. Or if the test comes out positive, then we have to test 11 times, because the first time we have tested and it has come out positive. Then we have to test a sample of every single person. There are 10 people plus that's 10 samples plus 1, that's combined sample of all the people. So that means there are 1 or 11. So for each group, the average number of tests equals to P1 into probability of k equal to 1 plus 11 into probability of k equal to 11. That means probability of all 10 people are negative. So if all 10 people are negative, the probability is 0.9 into 10 to the power 10. Probability of 0.9 into 10 to the power 10. So that's probability of 1 tested negative, and probability of 10 people tested negative is 0.9 into 0.9 to the power 10. That plus when not all 10 people are negative, so that will be 11 into not all. So if all are negative, that's 0.9 to the power 10. If not all are negative, that's 1 minus 0.9 to the power 10 into 11, because we are doing it for 11 people. So this is our formula, or we can say the expression for a group of 10 people. When we consider 100 people, the formula will be 10 into the above sample, 0.9 into 0.9 to the power 10 plus 11 into 1 minus 0.9 to the power 10. As there are 11 people, so there will be 10 different groups and different independent identity groups. So that means 10 groups, 10 independent different and identity group. So that means we'll consider this expression, we'll solve this expression. That turns out to be 7.5 into 10, that's 75.13. that becomes around 75 tests. So an average we'll have to do, if we do it in a group of 10 people, that's an average of 75 tests per 100 people that we need to do. Thank you.